Here I've got a Cyrus X Power stereo mono amplifier, and I've just taken the covers off, just having the first look inside, and I can see that we've got a capacitor here that's blown, and the equivalent on the other channel is also gone. I can also see that one of the fuses is gone. The other one doesn't look too clever, but I've not checked whether it's still alive or not. And I did put some power on this thing and we got some smoke, so I'm just going to try that again and see if we can capture that on camera. There we go. How good is that? Hey! So the unit's still powered up here, but the smoke seems to have calmed down, so that's helpful. It lets us then, what we'll do now is we'll go in and look at our power supplies on the little strip here, and we should have plus or minus, it says 42 volts, it's generally about 44 and a half on these last 2 points, so we're seeing plus 44, nearly 45 on that one. And then if we look at the negative side, and the negative side's reading minus 1.6, so that's clearly gone wrong there. The minus 15 is okay, and the plus 15 is okay, and our 5 volts is fine. And then if we look at these last 2 points here, they're related to either side of the fuse, so you're essentially meant to be able to probe these and tell if the fuse is gone. So if we look at this one here, we've got 44 and a half, and that's good. Looking at the output of the fuse, I've got 0, so that's expected because we know that this fuse is gone. If I look at the other side, however, where the fuse is good, then I've got my minus 44 rail there. Look at the other side of the fuse, and I've got plus 44, so that's completely wrong. Something's gone completely wrong there, that's why the fuse is gone, I guess, and perhaps why these capacitors are blown as well. So we need to get to the bottom of that, find out what's going on there. If I go back to the minus, this should, as I say, be sort of minus 44, and I read 1.6. Now these two voltages are to do with this circuitry here. There's a kind of voltage doubler and then a regulator here for the low power circuitry. And if I look at the collector of the transistor there, that's where I see my minus 1.6, 1.7. And if I look at the some of the other ports on the transistor, my input voltage is minus 84, so that's just fine. So you know, if that's all good, there's just something gone wrong here that's caused that circuitry to go wrong. If I look at the other rail, then you can see I've got my plus 84, and by the time we regulate it down, we're about 45 volts. So this section's fine, this one's gone wrong. So I think what we'll do now is we'll go in, we'll home in this area here and figure out what components have gone wrong to make that rail go wrong, and then we'll whip the fuses out and we'll look at the other part of the circuitry and see if we can figure out why these capacitors have blown. Other observations I can see is that someone else has been in here before me, because I can see there's a burn mark on this power supply cable here, and the soldering iron's been in there and burnt that. And I can also see, if I look in the side here, I'll take up a close-up shot, but these transistors have been replaced and they're not mounted correctly. They're not in full contact with the body here, they're not in full contact with the heatsink, and the insulating washer, it's not fitted properly either. I can see that the metal tab on the transistor is actually touching the chassis. So that could also be, it could cause some of this stuff to go and potentially cause these rails to go funny and do the damage that's happened. So I've checked out the minus 44 volt rail there, and I found that a bunch of transistors and Zener diodes and a resistor, they're all gone. and you know, I've seen this so many times actually on these amplifiers. I think actually the Zeners are probably underrated for the job, and after some time they just give up, and that takes out the transistors, and then the supply rail goes wrong. Either the transistors go open or short, so you end up with essentially 0 volts, which is what we had. We had about 1.6, or you see the full voltage on the output. So as I say, I've seen it happen so many times. This is definitely a weak area of circuitry. The other thing that looking on the output side, I can see that these transistors here, both of them, are actually just dead short. So that's no good, and that's maybe the reason why the output rails were reading funny. So what we'll do now is I'm going to have to order some parts for this a voltage doubler and negative rail here. But in the meantime, what we'll do is I'm going to also obviously have to order these transistors. But in the meantime, we'll take them out. We'll take out the transistors and we'll take out the 2 dead capacitors. And we'll see then if our supply rails make more sense. And then we can kind of be confident that we're on the right track. Hopefully the sort of the driver transistors are okay, but we'll check them out once the board's out. So we've got the screws out, and let's lift the board down and see what we've got. And look at this. You know, the transistors have been replaced, and some proper bodger's been in here. You know, the joints are absolutely terrible. Solder everywhere, and then there's some green stuff here. Looks like something's growing actually, but I see it in this trace here, and this trace, and then this trace. So I'm not sure what's going on there. Anyway, it's a proper mess here. So, but we'll go ahead. We'll take the transistors out, and we'll continue with our plan. So the transistors are out now, and the pair on this side, they were okay. These ones on the far side, they're dead short as we showed before. And then one of the driver transistors, unfortunately, it's gone as well. And as I mentioned, these have been replaced before, very badly. But also what I can see is that these capacitors that blew, they've also been replaced. And I can actually see even in this one, they appear to be second-hand capacitors. And there's a bit of wire just tacked onto the side of the pin of this one to try and make it a bit longer so it would go through the board. So this is really kind of shocking. I'll take a close-up of that one and show that. So anyway, these are removed, and we're hoping that our voltages are now showing something more sensible. So if we go to the far side first, I can see there we've got our 44 volts on one side of the fuse, which is not there, and then we look on the other side, and that's essentially reading 0, so that's what we expect. If I go to the other side, however, I've got my minus 44 volts, and that's okay, and then check on the other side, and I've got minus 40 volts, so there's something there not quite right yet that we need to check on. So I'll go and dig into that, see if we can find out why we've still got some residual voltage there when the fuse is removed. And it's not the case that we've got a low current supply driving that side, because we've already taken the negative rail out. If that sort of minus 44 volts was there, then I could understand this, but it's not. So something's to be understood there. So we'll dig a little bit deeper into that. What we find then is that we've got some protection diodes here between the supply rails and ground, and this one here is measuring dead short. And we saw earlier, a trace underneath that had some sort of green gunk on it, and it looks to me like that trace has burnt, and then so there's been a wire link put in there, and then the green stuff is some kind of insulation. However, that via pops out here somewhere, and then there's another trace that takes it to the star ground point, and this trace here is burnt. So the diode is short circuit, and because we've got a very thin trace, the trace is just got an open circuit. And again, because the diode is short circuit, what we find is that there's a resistor here, 47k resistor, and I think that must be just to bleed these big capacitors. So that resistor, with the diode being short, the resistor's essentially across where the fuse would be, and that's why we're seeing some negative voltage on what should be the cold side of that fuse. So what we'll do is we'll fix this trace, and we'll change the diode, and I think that we should then be reading 0 volts at this point. So what I've done here then is I removed this diode. We'll replace that when I get a new one, and then you can clearly see the broken trace there. That trace is just burnt away, and so I've this is just some copper tape that I've soldered in place of that trace, and I've put some conformal coating on that. I don't think you can maybe see a kind of shininess on the camera there, so there's conformal coating on that to insulate that. So we'll let that dry, put the capacitor back in, and then go and measure the voltages again, and hopefully that should be quite good. I will cut this trace away, I just left it to show. Alright, we've replaced the main capacitor after that conformal coating had a little time to dry. So now let's go and check our voltages again, and this side was the one that was reading wrong before. So as before, on the hot side of the fuse holder, minus 44 volts, and before we had minus 40 on the other side. If we measure now, we're getting 0 volts, so we're quite happy with that. That's been the cause of that problem. And then just checking on the other side, plus 44 and 0. So again, that's all good. So that's about as much as we can do right now. We need to order up the parts to replace the dead pile here, and so we'll resume in a few days once we've got these parts, and we'll start to put this back together.